A long time ago, we learned that we can make machines that can perform tasks that would otherwise be impossible for us to achieve using our own natural strengths and abilities. By cleverly combining bodies of various shapes and sizes using joints that guide relative motions between those bodies, we learned how to create mechanical systems that allowed us to transform the world around us and accomplish staggering feats that distinguish us from all other life on Earth. We learned how to use these mechanical systems to construct our homes and cities much faster and larger than would otherwise be possible, transport us more rapidly to places much farther away than we could ever travel on foot, manufacture products and clothing with greater efficiency and at substantially lower cost than could ever be made by hand, entertain us in new and exciting ways, tell time more accurately than we could ever have thought would be possible, think using artificial intelligence to solve problems that are difficult to solve on our own, and even go places we can't currently go. Hi, I'm Professor Hopkins, and in this lecture series, I will teach you about the fundamental building blocks that constitute mechanical systems such as cleverly shaped rigid bodies, gears, pulleys, belts, and sprockets, to name just a few. I'll teach you how these building blocks can be joined together using traditional rigid joints such as Revolute and Prism joints that guide their bodies in complex ways to achieve extraordinary tasks. Specifically, you'll learn how to analyze the position, speed, and acceleration of every point on any body within a moving mechanism, as well as calculate the forces and moments that the moving mechanism experiences. Now, you might be wondering why I would teach a class about traditional rigid mechanisms when my area of expertise is compliant mechanisms. Well, the reason is that it's easier to understand the principles of analysis in the context of rigid mechanisms first. But trust me, many of these same principles can be applied to determine the kinematics and kinetics of compliant mechanisms as well. If I have you excited to take this course, I'm glad, but don't be deceived. This course is not as engaging or entertaining as my compliant mechanism design professional video series. Similar to my compliant mechanisms lecture series, this course consists of raw, unedited recordings of the actual lectures that I use to teach my undergraduate students at UCLA. So these videos are not suited for everyone. They consist almost entirely of college-level mathematics and thus aren't generally accessible to most. But check them out and see what you can understand. I hope they're at least useful to some of you out there, and in any case, thanks for watching The Facts of Mechanical Design.